Hi, today we're going to look at perpendicular lines and some theorems about them. The definition of perpendicular lines, perpendicular being this symbol, is two lines that intersect to form right angles. In our example here, we have lines AB and CD, and if we're told that they are perpendicular, the definition allows us to say that each of these numbered angles is 90 degrees. The converse of that definition also is true. If we are told that angle 1, 2, 3, or 4 is a right angle, then we can say that line AB is perpendicular to line CD. Some theorems about perpendicular lines. The first one says if two lines are perpendicular, then they form congruent adjacent angles. The angles that we were talking about up here, 1 and 2, they would both be congruent because they both be 90 degrees and they are adjacent. The same thing with 3 and 4 and any other pair of adjacent angles that you could pick. The next theorem, if two lines form congruent adjacent angles, then the lines are perpendicular. That's just the converse of theorem 2-4. If we know that angles 2 and 4 are congruent and adjacent, then we have to say that these lines are perpendicular. Theorem 2-6 says if the exterior sides of two adjacent acute angles are perpendicular, so let me draw two adjacent they're sharing a side. We have two adjacent acute angles. If we know that their exterior sides are perpendicular, then those angles are complementary. And we just reviewed yesterday that complementary angles are two acute angles that add to make 90 degrees. And our last two theorems, theorem 2-7 says if two angles are supplements of congruent angles or of the same angle, then those two angles are congruent. So if we have two angles that are supplementary to the same angle, mathematically they have to be the same degrees. And theorem 2-8 is almost the same thing, but with complementary angles. If two angles are complements of congruent angles or of the same angle, then those two angles have to be congruent. And we're actually going to look at a proof of one of those angles right here, or one of those theorems right here. We are given that angles 1 and 2 are supplementary, angles 3 and 4 are supplementary, and we're given that angle 2 is congruent to angle 4. So I started the proof by writing out the given, two parts of the given, that 1 and 2 and 3 and 4 are supplementary. And because of the definition of supplementary angles, we can say that both of those pairs equal 180. We can use substitution to get the measure of angle 1 is plus the measure of angle 2 equal to the measure of angle 3 plus the measure of angle 4, since both of those quantities were equal to 180. We can then use the second part of the last part of our given, that angle 2 is equal to angle 4, and then that will allow us to subtract angle 2 and angle 4 from both sides, leaving us with angle 1 equal to angle 3. So that is a proof of theorem 2-7.